Hello and welcome to Apache Kafka Beginners Tutorial on YouTube channel of tutorialspedia.com. This Kafka tutorial is part of a series of video tutorials covering different basic as well as advanced topic related to Apache Kafka. Here is the detail of what we are going to cover in this video tutorial. Since this is the first tutorial of this playlist and of this series on Apache Kafka, so this will be a basic introductory tutorial where we will be covering a basic introduction and high-level overview of Apache Kafka. Then we will talk about the significance of Apache Kafka and some of the salient features that it possesses. Then we will talk about the Kafka architecture and we will talk about different components that are part of Kafka architecture, and then we will shed a light on Kafka concepts. Different basic concepts that are associated with Kafka will be covered in this video. And last but not least, we will talk about certain use cases associated with Kafka. Before I proceed with this video, I request you to please don't forget to subscribe to the channel and press the bell icon so that you are notified for any new videos uploaded related to this topic on this channel. All right, so let's first have an introduction and a high level description of what Kafka is. Kafka is an open source event streaming and messaging system which has capabilities to handle huge flux of data with its distributed fault tolerant architecture. So, in general, whenever we have multiple systems and we have multiple sources which are producing certain events and some data related to those events, and we have some other applications and systems which are interested in that data, and it's important for overall flow of that set of messages between these systems. Then it becomes very important for any organization that the messaging systems that they are using should be capable of handling huge flux of data, and it should be highly scalable, and it should be fault tolerance in those messaging platforms, so that we don't lose any data and we don't have any delays and we don't have any latency involved. So the good thing about Kafka is that this open source events processing event streaming platform does possess all these features, and it's capable to handle millions of messages per second. If we talk about the origin of this Kafka messaging system, it was originated at LinkedIn, and it was used by LinkedIn for its own internal processing. But later in 2011, it was made public under the Apache license, and then it became a common use for many organizations at a higher level of message communication to process millions of records and messages between different systems in an efficient manner. And this Apache Kafka works with publish subscribe mechanism, where we have publishers which are publishing and producing and publishing the data or the messages, and then we have subscribers which do subscribe to the messages topics of their concern or their interest, and then they receive the data. We will talk about this thing in detail in subsequent slides. So if we talk about the internal implementation of Apache Kafka, basically it's written in Java and Scala, and it's quite rich in terms of features as well as it's quite efficient in terms of its functionalities. So first, we need to talk about the significance that Kafka has and why companies should use Kafka. So let's talk about this. The first thing about Kafka, for the first positive thing and positive aspect of Kafka is that it's highly efficient. It's able to handle high velocity and high loads of data with ordered delivery. So this single sentence consists of many points that we need to take into consideration. The first thing is that it's highly efficient, which means that we don't have too many cases contrary to some other messaging systems where we have certain data losses. But here in this case it's highly efficient, and it has a great throughput, and it can handle millions of messages per second, which fulfills the need of most of the organizations. When we talk about high velocity, it means that in many cases we have real time events, like we have the cases where we have certain sensors which are passing data every second. So every second we are getting thousands or hundreds of thousands of messages. So in those type of situations where we have high velocity of data and high loads of data, in that those scenarios, Kafka plays perfectly fine and it does the job in an efficient manner. And the good thing that Kafka does is that it ensures order delivery through through the mechanism that is built into Kafka in terms of offsetting, in terms of the persistence, and in terms of the way messages are being stored. We will talk about this in subsequent slides as well. The second significant point that is associated with Kafka is that its architecture supports fault tolerance, making message communication and even processing robust and reliable without data losses. So in any organization, faults cannot be tolerated and data losses cannot be tolerated, especially in case of certain data critical and time critical applications. So if we are using Kafka, Kafka makes sure that the way its architecture is built and the distributed mechanism that it has with multiple systems handling the data and built-in default persistence mechanism that it has, all these features that are part of the Kafka architecture make it highly robust and reliable with its fault-tolerant mechanism. The next point about the significance of Kafka is that its persistence and message replication features make it highly durable. So what happens is that any messages that are produced by the publisher and published to the Kafka clusters, they are replicated as well as they are persisted. So replication is an additional thing, but the persistence is by default there in Kafka. So whatever messages that you are sending, they are not going to be just stored in memory, rather they are going to be persisted in the disk. So in this case, we achieve higher durability with Kafka. The next point is that Kafka is highly scalable, and horizontal scaling in a distributed clustered environment helps to handle any future business growth. So, in any organization, whatever is the flux of messages that are currently being consumed or produced, every organization or every growing business expects this number to grow in future. And there are cases where we have exponential growths as well in these type of messages, depending on certain factors. So it's important for any organization that the messaging platform that they are using is scalable and it's able to handle this type of future loads and future growth in terms of total messages being communicated. If we talk about Kafka, Kafka has this feature of a horizontal scaling, since it works with a clustered approach, where in a cluster we can add additional resources, means we can add additional brokers, and we can make sure that we do the partitioning, we do the replication, and all these features in an efficient manner so that we are able to achieve these goals. So now let's talk about the architecture of Kafka. This is at a higher level. We are talking about the architecture and different players which play a part in Kafka architecture. So we have producers which are producing the messages. So what producers do is that they produce message, they produce the events, and those events are published to the Kafka cluster. When we say Kafka cluster is basically a combination of multiple brokers. So we can have n number of brokers in a cluster, and all these brokers together make it a distributed fault tolerant cluster. And within these brokers we have topics. So topic is what where topic is the point where all the producers are producing and sending the messages. So once a producer produces a message, it sends to a certain topic. So the topic is just a category. You can consider it as a category of messages. For example, there can be a topic for some temperature information. There can be a topic for some real-time information for some transportation services. So this is just an example that there can be any topic which is a category of messages. So all the messages that are produced specific to that category are sent to that topic. So within the topics we have partitions. So this partitioning of topics, so any topic can have n number of partitions, minimum one partition, and it can have any number of partitions. So using this partition, we are ensuring another layer of distribution and a distributed architecture, in distributed environment within the Kafka architecture. We will talk about these topics and partitions in much detail in subsequent slides. And if we talk about the consumer side, we have multiple consumers which are showing interest into these messages, and they are consuming the messages, are subscribing the messages from these topics. So if we see here in this diagram, we can see that consumers can also be clubbed together into the consumer groups. So if we have multiple consumers which are made part of a consumer group, then what happens is that any message can be consumed or subscribed by only one consumer from a specific consumer group. So in this case, we make sure that messages are consumed by the group, but it is consumed by only one consumer within that group. So in this way, even on the consumer side, we are attaining fault tolerance, and we are making sure that we have multiple consumers in a consumer group. So if one consumer is not able to subscribe or consume a certain message, there is other consumer in the same group which can consume the message. And all this communication within the cluster is managed and controlled and governed by the zookeeper. So zookeeper is our management service in this case for the Kafka cluster, which is making sure that all the brokers are able to communicate and coordinate with each other. So if any of the broker goes down, or if any new broker is added, or if any new topics are added, all these type of information is controlled and managed by the zookeeper. So now let's talk about some of the basic concepts which are associated with Kafka. So the first concept that we are going to talk about is Kafka Producer. So Producer is the source which publishes events data to Kafka Topic. So a Kafka Producer can publish messages to one or more topics. As I stated before, topic is a category of messages. So a producer doesn't necessarily have to produce message for only one topic. There can be scenarios where a producer is producing the message, and the same message or a copy of the same message is published to multiple topics. And Kafka messages produced by the producer contain the information about the topic and its associated partition to which message should be written. As I stated before, that topics are subcategorized into the partitions, and a single topic can have multiple partitions. So, whenever a message is produced and published by a producer, it does contain the information that this message should go to which particular topic and which particular partition. Kafka Producer doesn't wait for the acknowledgement from the broker to ensure faster delivery. So once a message has been published from the Kafka Producer, there is not going to be any synchronous type of wait on the producer side to wait for the acknowledgement. Rather, it's going to continue its subsequent actions to produce and publish new messages without waiting for the acknowledgements. As you can see in this diagram that we have partition 0, partition 1, partition 2. So all these partitions have offsets. We will talk about these offsets when we will talk about the topics in subsequent slide. And based on these offsets, what happens is that the new messages are written to the on the top. So the old messages are written with the initial offset. For example, on the partition 0, the first message will be written at offset 0, and then subsequently it will be written in offset 1, 2, 3, 4, 5, 6 onwards. So the latest message that is going to be written will be written in the next available offset. So this ensures that we have an ordered delivery of the messages from the publisher to the partitions within the topics. The next concept we are going to talk about is Kafka Consumer. Consumers subscribe, which are also known as subscribers, they read the messages from the Kafka topics based on their subscription. So whenever there is a producer which publishes the message to a topic in a certain partition within that topic, then we will have some consumers who are interested into that particular topic category. So what they will do is that they will subscribe to that topic, and then they will be pulling the message from that topic. So it's important to understand here that producers, after producing the message, are pushing the messages towards the topics, but consumers have to pull the message. So it's not the case that broker is going to push the message directly to the consumer. Rather, consumers will have to actively pull the messages from the topics. So we can have multiple consumers which we can group as a consumer group. A message from a topic is consumed by only one consumer from the group. So we can see here in this diagram that we have producer A, we have producer B. So these producers are producing the messages and publishing to certain topics. We have topic A with partition 1, partition 2, partition 3, and we have another topic, topic B with partition 0. So it has only one partition. Then we have consumer groups. We have two consumer groups in this case. We have consumer group 1 with 3 consumers. We have consumer group 2 with 2 consumers. So you can see that any particular message in a topic can be consumed by only one consumer in a group, but there is a possibility that a message in a topic in a certain partition can be consumed by a consumer in one consumer group as well as another consumer in another consumer group. As you can see in case of topic A, partition 3, there are consumer 5 as well as consumer 3 can get the subscription and can consume the same message. The next topic that we are talking about is Kafka Topic. Topic is a stream of messages belonging to a specific category. If you talk about topics, they are divided into partitions. So each topic has minimum one partition. So whenever you create a topic, by default it has one partition. But if you want, you can add multiple partitions for the same topic. Messages in a partition are stored as immutable, which means that we cannot edit or we cannot change the topic, change the messages content, and are in ordered sequence with an offset. So there is always an ordered maintained for the messages which are published to any topic in any partition within that topic. In Kafka, replication can be done at partition level. So each partition can have one or more replicas, meaning that partition contains messages that are replicated over a few Kafka brokers in the cluster. So using the replications, we can make sure that the messages are replicated in multiple within our cluster among multiple brokers. So this can also ensure that we are achieving high availability as well as we are not getting any data losses for our messages that are being passed and communicated through the cluster. Replication works on the leader follower principle. So what happens is that we have one replica which acts as a leader and all other replicas which we have created they act as a follower. So what happens is that all the read write operations are governed and managed by the leader, and all the followers only replicate the leader. So whatever follower have to do is just to replicate whatever changes have been done by the leader in terms of read and write operations. So in case the leader goes down for any reasons, then one of the followers takes the charge as the leader, and then it manages all the read write operation for that cluster. So here in this picture, you can see we have partition for a certain topic, partition 0, partition 1, partition 2. So what happens is that all the read write operations are done at the last offset. For example, for partition 1, the next read operation, write operation, not read, it will be write operation, sorry. So the write operation will be on the next latest offset, which is offset 4, which I mentioned here with the color green. So partition 1, the next message will be written to offset 6, and partition 2, next message will be written to offset 2. So in this way, offsetting is done in any topic partition to make sure that whatever messages are produced by the producer and sent to a topic, they are written to the topics partition in an ordered sequential manner. So next we will talk about Kafka broker and cluster. A broker is a central server in a Kafka environment which is responsible for providing services to producers and consumers for storing and retrieving the data. So broker is the central server. So what happens is that whenever producers produce the message or whenever consumers have to consume the message, they rely on brokers. So broker is responsible for making sure that it is providing the required topics, and within the topics we have the partitions. So it's if we have a collection of brokers in case of a clustered distributed environment, then it forms a cluster. So it's called a Kafka cluster, which is consisting of multiple brokers. So in this way, we are achieving distributed and fault-tolerant event processing within the Kafka architecture. And a cluster, when we have a cluster of multiple brokers in our Kafka architecture, there must be someone who is responsible for coordinating and managing all these brokers within the cluster. And that job is done by the guy named as Zookeeper. So Zookeeper is managing the cluster and it's making sure that all any changes that are happening within the cluster. For example, if some broker is going down, if new broker is getting added, if some partitions have been changed, or there is any changes in terms of topics or replication or anything else related to that Kafka cluster, it is communicated to all of the brokers within that cluster. So this type of management jobs are handled by the zookeeper. So let's talk about the zookeeper in more detail. Management and coordination of Kafka brokers in a cluster is achieved through the zookeeper, as I stated before, and it notifies all the nodes when the topology of the Kafka cluster changes. For example, whenever new brokers and topics are added, or whenever any brokers or the topics are removed, or whenever any of the broker goes down, or whenever we have to make sure that any partitions or any other information is getting updated or changed within the Kafka cluster. And Zookeeper also controls the leader follower selection among the multiple brokers. As I stated before, that whenever we have multiple brokers, we have leaders and we have followers. So when a leader fails, what happens is that this is the responsibility of Zookeeper to manage this type of scenarios. And what happens is that another broker from the followers takes charge as a leader. Same is the case in case of replication as well. So now let's talk about the Kafka use cases. That what are the scenarios? There can be plenty of scenarios where we can use Kafka, but we will just talk about a few. So the first use case where Kafka can play an important role is stream processing. Stream processing to stream, aggregate, enrich, and transform data from multiple sources. So let's suppose we have the scenario where we have multiple sources of events which are going to stream the events, and we want to make sure that we not only receive those events but also we aggregate the data according to our requirement. We do the enrichment, we do the transformation and translation of data, and then we want to make it available to the consumers in a separate topic or in the same topic. These type of actions can be performed by the Kafka, and Kafka streaming will make sure that we do the aggregation and enrichment of data in an efficient manner. The second use case can be that we have a website, maybe it's a shopping related e-commerce website or any kind of website where we want to monitor and track the activities of the user. So what happens is that in this case, if we use this type of messaging platform, a public subscription mechanism of Kafka, then all the activities that are being done on the website can be monitored, and then events can be generated and sent to the Kafka cluster to its brokers. And then we can have the consuming applications or consuming system which can consume those type of events data and perform whatever action they want to perform. For example, there can be analytics dashboard, there can be certain certain corrective action, there can be certain operational requirements or operational actions required based on the tracking of the activities on the website. The next use case can be applications health monitoring. We can have a scenario where we have multiple systems and applications in our organization, and we want to make sure that we monitor the health of those applications in an efficient manner. So, what we can do is that we can achieve this using Kafka by making sure that all of these applications in real time are sending the events in terms of the important data to the Kafka cluster, and then we have our monitoring applications, our monitoring platform, which is looking into the events and then performing certain actions. So in this way, we can monitor the health. Like we can have the case that in case of CPU utilization of memory resources or any other resources of certain servers go beyond a certain threshold or a limit, then we can trigger an event, and based on that event, we can take the preemptive as well as corrective actions. Then we can also think of using Kafka as a messaging platform for real-time messaging as a replacement of traditional messaging systems. Like traditional messaging system means RabbitMQ, or we have ActiveMQ or JMS. So if we want to achieve a higher throughput and we want to ensure a better distributed and fault tolerant capabilities for our messaging platform, and we expect a higher load of data and higher velocity of the messages, then we can opt for Kafka as a replacement of those traditional messaging platforms, and we can achieve better results. So this is just a basic example of certain use cases. You can have plenty of other use cases where you can utilize the powers of Kafka. That's it from this video, and I hope that the information at a higher level that has been communicated in this video is helpful for you, and you should be in a position to understand the basic concepts which are associated with Kafka. If you have any questions, or if you have any concerns, or if you have any ambiguities, feel free to put your question in the comments box and your feedback as well, and I'll make sure that I respond to your questions and your concerns. And again, please don't forget to subscribe to the channel, as more is yet to come, and we will have many more videos related to this topic as well as other integration related topics. Thank you very much.